Let's take a look at one like number 35. Here we're integrating from 1 to a, the function 8x plus 3, and we're finding all the values of a such that this definite integral evaluates to -7. Oh, sorry, -7, -6. And so how do we proceed with this? Well, first of all, we're going to evaluate this definite integral over here. Okay, so how do we do that? We find, by the fundamental theorem of calculus part 1, we're going to find the antiderivative of 8x plus 3. So the antiderivative of 8x is 4x squared. I hope a lot of you, again, can do that real quick. Okay, and then the antiderivative of 3 is 3x. So I hope this comes pretty quick. And then we're going to evaluate this at the upper limit of a. So I plug in a here, and at the lower limit of 1. So notice when I square 1, I get 1, so I get 4 plus 3, or 7. So don't forget you're subtracting here. So it becomes 4a squared plus 3a minus 7. Now remember, this all was supposed to be equal to -6, which I've written over here. So now I have a quadratic equation to solve. How do I solve a quadratic equation? Well, the easiest way is to set it equal to 0 and see if you can factor. Or if you can't factor, then complete the square or use the quadratic formula. So here, I'm going to add 6 to both sides to get 0 over here. -7 plus 6 is -1. And then can I factor this? And it turns out, yes, you can. And so again, you've got to be able to factor in this course. If you're having trouble, factoring an expression like this, which factors like this, please get the help that you need. See me. Make an appointment with me. Do something to be able to get the help you need. Okay. You can use the AC method, grouping, trial and error, however you want to do it. It's pretty easy though to get. There's only, by trial and error, there's only a few trials. But here is the correct way that factors, and you can check, because first gives me 4a squared. The outer is 4a. The inner is -a. 4a and -a is positive 3a, and then last -1 times +1, of course, is -1. So then you have a product of two things equal to 0. So the zero product principle says what? That one of these two factors has to be 0. Either 4a minus 1 is 0, meaning 4a is equal to +1, or a is 1/4, or a plus 1 is 0, so a is -1. These are the two values of a that work. And now, as a check, could you check this at all? Yeah, go back to the original definite integral, and it's going from 1 to a. If I go from 1 to -1 of 8x plus 3, I should get -6. Now, some of you might be saying, wait a minute, how can the upper limit be smaller than the lower limit? And that's fine. You can have that. Don't forget, I can simply rewrite this as what? I can change the order of the limits of integration if I want to by doing what? What do I need to do there? I need the negative sign out front, right? Just changing the order of integration, or the limits of integration, will change the sign. And I'll let you figure this out. Go ahead and check, evaluate either one of these integrals and see that it comes out to be indeed -6. Similarly, if you go from 1 to 1/4, the antiderivative of 8x plus 3, that should also give you -6 as well. So that's a check. But again, when they say find all the values of a, you've got to do that. You just can't plug in different values of a into this and keep trying and trying and trying until you get -6. That's not how you show support. You show support by just plugging, doing the fundamental theorem of calculus and then solving that resulting equation that you get. Okay, hope this makes sense for these, and we'll do some more later.